but they're all purposeful tabs. Mainly Love is Blind. Okay, that's the most important tab, but yep. YouTube for my YouTube channel, very important, as you know. Okay. All right, so guess what? Okay, we are starting a brand new unit called related rates. Okay, the first day of this isn't too bad. Okay, but if you don't understand the first day, you're going to really have trouble for the next few because we're going to be doing word problems for the majority of this unit. Okay, but it's going to be okay. We're going to start off with kind of like a bite-sized chunk. Okay, so up here at the top. Okay, you should know that when you take the derivative, you're getting a slope. Okay, and slope is basically how fast the y value on a graph is changing. So now we're going to expand that. Instead of looking at a graph where the derivative tells you how fast the y's are changing, okay, we're going to have a rate. That's what this word said before it got hole punched. Okay, a rate is going to be how fast any quantity is changing. Okay, another big difference is going to be instead of taking the derivative with x as your independent quantity, for word problems, typically you're going to use time as your independent quantity. So instead of your derivatives being d dx, they're going to be d dt, where the t stands for time. Okay, so if you want to put a little note over here, your independent variable is going to be time. So whenever you see the word rate, that's telling you how fast something is changing. So let's just practice writing some rates just to kind of give you the idea. So look at number 1. It says, the volume of a cylinder is increasing at a constant rate of 5 cubic centimeters per second. If it's the volume increasing at a rate, that would be dV/dt. Okay, where ddt stands for how fast something's changing with respect to time, applied to my v would be volume. Now, if it's increasing, then you're going to let it equal a positive number. Just like if it was decreasing, you would let the rate equal a negative number. Okay, then it says 5 cubic meters would be meters cubed, and then per second. So that tells you that the volume is growing 5 cubic meters each second. Okay, take a look at number 2. It says the height of the water in a pool is decreasing at a constant rate of 2 inches per minute. So the quantity that I'm measuring last time was volume. This time it's height. So what do you guess I'll put? D what? dH dt. Where the H is standing for height. Now, last time, okay, my volume was increasing. This time, what's the height of the water doing? Decreasing. So instead of putting equals 2, I'm going to put equals -2. And then my units are inches per minute. Okay, next one. At rush hour, the number of vehicles passing through an intersection is increasing at a rate of 82 cars per hour. Okay, this one isn't like volume or something like that. So we're just going to put N for number of vehicles. I would put dN dt. This is how fast the number of vehicles going through an intersection is changing. And it says it's increasing. That means positive. And then 82 cars per hour. All right, last one. The air in a balloon is escaping at a rate of 15 cubic centimeters per second. Okay, what measurement is how much air can fit in a balloon? Volume, very good. So the air in a balloon, that would be dV dt. and then it's escaping at a rate of 15 cubic centimeters per second. Remember, cubic centimeters and centimeters cubed are the same thing. Okay, and then it was per second. Okay, now read through number 4 again and tell me what I need to change. Negative, because what's the air doing? It's escaping. That means the volume would be getting smaller, so we would need a negative here. Does that kind of make sense? Okay, before we get into any word problems, let's just practice some derivatives. But remember, all of your derivatives are with respect to what? Time. So when I took the derivative of y, I had to add a dy dx. So now if I take the derivative of any letter, I'm going to have to add a d letter dt. So here's what I mean by that. Okay, take a look at, let's do number 6. Okay, v equals L cubed. This is the volume of a cube. What is the derivative of v going to be called? Okay, v prime, but let's do d v dt. Okay, so that stands for the derivative of volume with respect to time equals. What's the derivative of L cubed? Huh? Okay, so we're going to times the 3 down, so it'll be 3L2 dl dt. Okay, but because you're taking the derivative with respect to time, and L is not a t, you have to put a dl dt at the end. Okay, let's do another one. Let's do perimeter. Okay, look over here. Perimeter equals 2L plus 2W. What is the derivative of P going to be called when I take it with respect to time? dP dt. That stands for the derivative of perimeter with respect to time. What is the derivative of 2L? 2 what? dl dt. Because remember, L is a letter other than T. Okay, my next one is a 2W. What's the derivative of 2W? 2 then dW dt. Okay. Let's jump down here to area of a circle. Okay, area is pi r squared. This is formula number 12. What's the derivative of A going to be called? dA dt. Now, quick question. The derivative of A is just what number? 1. So this is really 1 dA dt, but rather than writing the 1, we're just going to put dA dt. Okay, on the other side, I'm going to take my 2 times it down to the front. What do I have in the front now? 2 times pi is 2 pi. And then what do I do to my r squared? Now it's just in r and then dr dt. So whatever your letter is, if it's an L for length, W for width, R for radius, you're going to add ddt of that letter to the end of your derivative. Okay, let's back up and take a look at number 10. How many variables are in your area of a triangle formula? It's A equals what? 1/2 B times H. Whenever you have mix and match variables, what rule are we going to have to use on that? Product rule. Very good. So underline your 2 pieces, and I'm going to put this needs product rule. Okay, just like, do you remember when we had x's times y's in the same term and we had to do product rule? It's the same thing here, but instead of x's and y's, it's a b and an h. So let's split up our product rule. U is going to be 1/2 b, v is going to be h. What will u prime be if it's the derivative of 1/2 b? 1/2 what? dB dt. Very good. Okay, remember the derivative of 1/2 b is 1/2, but then I just attach the dB dt to the end. What about the derivative of h? What number will I get there? 1 and then 1 what? dHdt, and you can write the 1 or not, that's up to you. Okay, now let's write our derivative. So the derivative of A is gonna be called what? dA dt. And then remember, for product rule, you're multiplying the diagonals and then adding them together. So it's gonna be this times this, plus in the middle, this times this. So let's write that down. Okay, order doesn't matter, but I'm gonna do this diagonal first. So it'd be a half B dH dt plus, and then a half dB dt times H. But keep in mind that this is all one term, plus this is all one term for product rule. Okay, let's do a couple of the weird formulas down here at the bottom. Let's do, which one will need product rule? First two or last two? Okay, these are both gonna need product rule. Okay, so we'll save those for another day. Okay, but the last two are not gonna need product rule, and here's why. Pi is a number. So 4/3 pi in front of an r cubed, you don't need product rule for that. So let's take the derivative for, let's do the surface area. Okay, what's the derivative of A gonna be? dA dt. And then for the 4 pi r squared, I'm taking the derivative. The 2 is gonna times down on the 4 pi. What's that gonna be now? Okay, 2 times 4 pi is 8 pi. My r was squared. What is it now? Regular r, and then dr dt. Okay, do we kind of get the idea? Okay, go ahead and turn the page. You do, but it's gonna be spread out over a couple days. Because, I mean, your notes, we won't get through all of them.
I was hoping.
You were hoping? All right, for number 1, I want you to write down the following words on the left side of your paper. Find, given, when, and equation. Okay. So find usually is going to be the rate that you're solving for. So I'm going to put here the rate you need to solve. Given is going to be the rates you have, okay, that they tell you in the question. Okay, and then also it's going to be any fixed, what should we call this? Fixed constants. Okay, when is going to be a particular value or a changing constant. Or we'll put changing variable. And then the equation, you have a whole formula chart on that front page that we'll be referencing over and over again. Okay. So once you have that written down, we're going to go back and we're going to read number 1, and we're going to try to fill in the rate we're trying to find, the rate we're given, whatever our whens are, and then we'll go back and look for our equation after. So it says a pebble drops into a pond, causing ripples in the form of concentric circles, the circles that just get bigger and bigger. Okay, then it says the radius r of the outer ripple increases at a rate of 3 feet per second. Okay, what is increasing at a rate of 3 feet per second? What quantity? The radius. So under given, I want you to put dr dt equals 3 feet per second. Dr dt, that's standing not for the word rate, but for radius. The radius is changing 3 feet per second. Okay, then it says, when the radius of the outer ripple is 4 feet, notice it says when, so R equals 4 feet. What rate is the area of the outer circle of the water changing or finding dAdt? Now, I want to point out to you something that's kind of important here. Let me box the things we just wrote before we keep going. Okay, as the stone falls into the pond, okay, is the radius always 4? No, it's only 4 at one moment and then it keeps growing. So that's why this says it's a particular value, but for a variable that is changing throughout the problem. Okay, versus up here, this is going to be something that's consistent. My ripple is always growing in the radius by 3 feet per second. So look back on the little front sheet. We're talking about a circle here. Find the equation for the area of a circle. Probably you already know it, but what is it? A equals pi r. So once you've identified your find, given, when, and your equation, you're going to take the derivative and then plug stuff in. Let's do it. So we did already do this one on the front, but let's just kind of work through it again. What's the derivative of A going to be called? Okay, write it down, dAdt. Then I'm taking the derivative of pi r squared. So I'm going to times the 2 down to the front. So now it's going to be a 2 pi. My r is going to drop to a regular r and then dr dt. Then from here, we're just plugging stuff in. Now, for the first few examples, I'm going to include the units, and then eventually we're going to stop doing that. So what is my radius including units? For what? Feet. Very good. So I'm going to have 2 pi times 4 feet. What is my dr dt including the units? 3 feet per second. Very good. So 3 feet per second. Okay, and that is equal to dAdt. Well, then let's find our final answer here. Let's just do a little bit of arithmetic. What is 2 pi times 4? 8 pi, and then times by 3? 24 pi. Very good. So my answer is 24 pi. Now let's talk about my units. I have feet times feet per second. What will my overall units be? Square feet per second. Correct. Now, I want you to kind of think about, does it make sense that I would be measuring area in square feet? Yes. What would volume have been measured in? Cubic feet. So if you want to kind of write that over here to the side, if you have area, it's going to be units squared. If you have volume, it's going to be units cubed. And then if you have a distance or a measurement, that's just going to be like regular units. So if it's like the length of a box or a radius or a height, okay, all of those would be linear. Okay, last thing I want you to do is I want you to write a little sentence to write what this means. So we're going to put, at the time when the radius is 4, the area of the ripple is increasing 24 pi square feet each second. So you're essentially finding how fast that quantity is changing. Okay, also keep in mind that we know that the area is increasing because our answer came out to be positive. Thank you so much. I'll send it.
No, tell them to take this up too.
Okay. Versus if it had come out negative, I know that that amount was shrinking. Okay, so go on to number 2 when you're ready. And I want you to try to find any part of the find, given, when, or equation. Matthew, it's for you. You do. All right, so a spherical ball is inflated with air at a rate of 800 cubic centimeters per minute. What is that measuring? Volume, and I know it, so I'm going to put it under given. dV dt is 800. Okay, then remember, cubic centimeters is basically centimeters cubed per minute. Okay, then it says, how fast is the radius of the balloon changing? What do I put for my find? d r dt. Okay, that would be for the radius. Okay, then it says, at the instant when the radius is how big? So r equals 40 centimeters. Okay, when you're ready, look back at your first page. What is the shape that we're dealing with? Last time it was a circle. It's a sphere because it's a balloon, right? So this is like a 3-dimensional circle. So look for sphere, and I want you to find the equation that relates B and R to each other. Y'all see it? You don't want to say it, or? Thank you. 4/3 pi r. Okay, and we're just pulling them off that front sheet that is kind of organized based on the shape. So let's take the derivative. What is the derivative of V going to be called? dV dt. Okay, now when I take the derivative over here, I'm going to do the 3 times 4/3. What am I going to get when I do that? What number? 4, because the 3's are going to cross out, right? I'm doing a times 3 on a divide by 3. Those are gone. I'm just going to keep the 4. So it's going to be 4 pi r what? Squared, and then dr. Very good. From here, we're looking to plug some stuff in. I know dV dt this time. What is it? 800. And then, like I said, just for these first few, I'm going to keep track of units, but then we'll stop doing it maybe after this example. So it's 800 cubic centimeters per minute equal to 4 pi, what's my R? 40 what? Centimeters, quantity squared. And then notice that dr dt is what I'm trying to solve for. So I know that I don't already know that, or I wouldn't be doing the question, right? Okay, from here, let's follow PEMDAS. Parentheses and exponent first. What is 40 squared? 1600, very good. Now let's take our 1600 and times it by 4. Very good. So I have 800 centimeters cubed per minute equal to 6,400 pi. And then my units would be centimeters squared dr dt. Now notice the reason my centimeters are getting squared is because they were with the 40 when we squared it. From here, I want to solve for dr dt. How do I get rid of this coefficient? How do we get rid of this if it's multiplied with the dr dt? We're going to divide it. So divide by 6,400 pi centimeters squared on both sides. So now we have this. dr dt equals And then on this side, little trick, if you have 2 zeros on top and 2 zeros on bottom, you can just ignore all 4 of them. So I'm gonna just kind of carefully cross out the 800 and the 6,400. That's the same as just 8 over 64. What is that gonna reduce to? 1/8. Now let's talk about our units. I'm doing centimeters cubed divided by centimeters squared. How many are gonna be left? Regular centimeters per minute. Okay, now, quick question. Think about your units. Okay, a radius is a distance. Does it make sense that it was measured in flat units instead of units squared or units cubed? Yes. Okay, part B of this same question. We're gonna have a new find and a new equation. But everything else is kind of the same balloon, filling at the same rate, blah, blah, blah. So here's what it says. How fast is the surface area of the balloon changing when the radius is 40? So now we're finding how fast surface area is changing. That's gonna be ds dt. And then I'm gonna write that the S stands for surface area. So flip back to your front sheet, look up the surface area of a sphere.
A equals 4 pi.
Oh, do they use A? Let's change it to an A then. Okay, A equals 4 pi r squared. Okay, rather than S for surface area, we're gonna use A because that's for the formula. Okay, from here, remember, your strategy is take the derivative, plug stuff in. What is the derivative of A gonna be? dA dt. Okay, take the derivative of that other side. So if it's 4 pi r squared, what would the derivative be?
8 pi.
8 pi r dr dt, very good. And then from here, we're just plugging stuff in, but now we know our radius. What's our value for our radius? 40. And then what's our value for our dr dt? We just found it. 1/8. So it'll be dA dt equals 8 pi. My r is a 40 centimeters. My dr dt is 1/8 centimeters per minute. And how did we get the 40? What happens with both 8s? They're gonna basically cross out because one's a times 8, one's a divide by 8. So these guys are gone. And is it just gonna be 40? 40 pi, very good. So dA dt is gonna equal 40 pi. Now let's talk about units. I have centimeters multiplied by centimeters per minute. What are my final units gonna be? Centimeters squared per minute. Question, are centimeters squared an appropriate unit for an area measurement? Yes. So if that doesn't happen, then you kind of know that something went wrong. Okay. How do we feel about that? Not too bad? Okay. Number 3, go ahead and take a look. See if you can fill out your find, given, when, and equation. Find, given, when, and equation. You will probably not be able to do all 4, but see if you can at least get 3 of them.
Wow.
Okay, R is 70. How fast does it say that it's melting? Huh? Okay, what's changing at 2 centimeters per minute? So you put dRdt. And then if the snowball's melting, is the radius increasing by 2 each minute? Okay, so what does it say we're finding, how fast what's changing? So reading this is how fast is that? So your spine is speed. And then it does tell you it's melting, but look what it says right here, the radius is doing what? So you can already see your radius.
I don't know.
You're good, but maybe behind. But the RD doesn't have that, the radius changing, why is it -2? Because this snowball is.
I don't know, but.
Then look up your coordinate for volume of a sphere.
Which one?
Yes. Oh, the when's the one you probably can't find. We're about to do it. No, it's just a curveball, you know, as I like to do. As I like to do. All right. Okay, this one does have kind of like a little tricky thing in it, but let's do it. What are we finding? How fast what is changing? Okay, we're finding how fast the volume is changing, but we're given how fast the radius is changing. How fast is dRdt going? No, not that number. It's decreasing at a constant rate of 2, so it'd be -2. Now, like I said, at this point, I'm going to kind of drop the units off and we'll just put them in at the end. But if you want to keep track of them in your notes, you can. Okay, now let's talk about the kind of weird thing. Your when is half an hour later. So I want you to put when half hour later question mark. Okay, now they also told us that the radius was 70, but that was before it started melting. So I'm going to put here the radius starts at 70 centimeters. Okay, let's do a little bit of this. This isn't even really calculus. This is just like regular math. Okay, how fast is the radius going down to what? Centimeters per minute. If I'm going to wait half an hour, okay, listen to the thinking here. Half an hour, how many minutes is that? 30. So if it goes down 2 centimeters every minute for 30 minutes, how many is it going to go down? 60. What did it start at? 70. So how many centimeters would be left? 10. Does that make sense? Okay, so I'm going to put over here R is 10. Okay, but you're going to just kind of have to piece that together. That if it starts at 70, I'm waiting 30 minutes, 2 centimeters per minute would be down 60. That would leave me with 10 left over. Okay, then look up your equation. We actually already did it. Volume of a sphere is 4/3 pi r cubed. And then I'm going to shortcut to the derivative because we just took it in the last question. So it would be dV dt equals 4 pi r squared dr dt. And then from there, we're just plugging stuff in. So it'd be 4 pi. What is my R value? 10. Because remember, we don't want to know how fast it was melting at the beginning. We want to know half an hour later, the radius is only 10 at that point. And then my dr dt was -2. What is 10 squared? 100 times 4 pi. That would be 400 pi, and then times that by -2. 400 times -2 would be -800 pi. Okay, then all the way down, that would be dVdt equals that value. Okay, from here, if you want to be a little bit lazy and not keep track of units, at the end, you just have to think about what am I measuring? What type of quantity? It's a volume. How do I measure volume? Cubic. So it would be centimeters cubed per minute. Okay, then I want you to write your little sentence on this one. Okay, so that we can kind of put the pieces back together on what we just found. Okay, at the time when the radius is 10, and then I'm gonna put half an hour later. The volume is decreasing negative 800 pi cubic centimeters each minute. And then I do want you to just kind of think about, does it make sense my volume's decreasing if my snowball is melting? Okay, yes, that kind of all should make sense. Okay. All right, we're gonna skip number 4 for a minute, and we're gonna go on to number 5. Okay, so I want you to start off with the find given when on number 5. And we're skipping 4, we're going on to number 5. She in that internship. I know, she's. That's on, I think.
You literally just add breaders in your food. But two.
Yes. I did see you maybe like tickling each other.
What they did was they took bread.
Okay.
And then two nuts.
My thing is like the texture of a banana to me is a nightmare. And then the texture of tuna is a nightmare.
And that was what I was smelling, cause he's right there, like,
I didn't know that it would smell bad, but I think the squishiness, and then I don't know if it gets y'all, but when I like bite into something and it like squirts out the other end, so I was like, oh, that's it. Like even if it's like a meatball sub, if it like is gonna squirt out, I'm like. But I'm glad you enjoyed your banana tuna sandwich. They're not bad. Okay, so what are we finding? So we're finding EAP. Okay, and then what rates were we given in? DWCP, if it's
No, not like my back, like my, let me drop.
and then it says the lean is decreasing. And then your win, it says, I want to pay this the area increasing with this description as your win, CW. Okay, then what shape is it? A rectangle, so go back to your front page, so looking for the rectangle. And then finds that formula. Now, before I walk away from y'all, if it's in all times that. You will be the L. You need to. Yeah. Okay. Thank you. Okay, so what are we finding? What rate of what? What rate is the area increasing? So it's DA, is what we're finding.
What number are we doing? Oh, yeah.
Then they tell you how fast the width and the width are changing. How fast is the width changing? So hold on, so let's read it to the beginning, because this is just when the width is for, that's a when. See, as my width is changing, but I care about when it is for. Okay, so for your when, the width is 4, and what is the length need? 5, very good. Now let's talk about how fast they're changing them for the rate. So read the first sentence, what does it say? The width? Okay, so it's increasing at a rate. I just like the WGT. For how fast the width is changing. Because it's growing at a rate. Now, what about for the length? It's doing what? So then DLDT is gonna equal negative. Does that make sense? Okay, then you're gonna look back at your front page for the equation for the area of that shape. What's the shape? Rectangle. So how do we find the area of a rectangle? Very good. Write it down for your equation. A equals LW. And then if you want to take the derivative of that, what rule are you gonna have to do? It's in LW.
Oh, there's.
Yeah. Okay, how we do it? Okay, now, for these two, they should go out here. So if it's how fast something's changing, your question.
Yeah, I know.
So it's equal this, what is this, what is this? Right, but what is changing at that rate? That was. Like that, but for now. Okay, then from there. DLDT should be, now that one's gonna be increasing at a rate of 3. Then from there, when you wanna take the derivative, the area of a rectangle is gonna be equation. What rule are you gonna need when you need to take the derivative? Yes, because it's L times W, that's. Oh, you do, sorry, when the W is 4 and the L is 5. And now notice one little difference there. The reason you have to link it to the W. Does that make sense? So the width is gonna keep growing, but I want to. That's not a GWT, that's a W.
I don't know more about.
So you're only gonna put the EDP on it, how fast it is. But now take the derivative of your area.
How do you use right? So now it's the top.
I'm lost.
Right.
That's right. And then it tells you the link when it's published. So put link this 5.
Let's do it.
And then get what is changing at 6 and. So put
It's like.
So your U. No.
Looks like an X. That was hot.
What rate should the area change then from there, you go back to your and then when you take the directive, you're telling yourself you are. So 18 is correct. Good job. Yes, you get 18. Yes, good. Okay, now we'll follow up, so you don't go over 18. All right. Okay, that's okay. Let's see what you do. All right. So you're given when you're finding dAdt, you were given that dWdt, that's how fast the width is changing, is 6. dLdt should have been a -3. Why is it minus for dLdt? Because the length is what? Decreasing versus the width was increasing. That's why it got a positive. Okay, then for your whens, we want when the width is 4, that would be W equals 4, and your length is 5, so L needs to be 5. From here, how do I find what is the equation for the area of a rectangle? LW, very good. Now, you should have done product rule, okay, but I'm just going to write the answer and hopefully you did it. Okay, it would be dAdt equals L dWdt plus W dLdt. Okay, and if you put it in reverse order, remember for addition, that doesn't matter. So we have dAdt equals, my L was a 5, my dWdt was a 6, my W was a 4, my dLdt was a -3. 5 times 6 is going to be 30, minus 4 times 3 is 12, and 30 minus 12 is 18. Okay, at the end, you want to think about your units. This is the rate of change of an area. So what should my units be if I was measuring in centimeters per second? What should it be for area? Centimeters squared per second. Okay, then there's an additional question on this one. It says, how fast is the area changing? And then it says, is it increasing or decreasing? That would depend on whether this came out positive or negative. How did it come out? So I would put then area is increasing because my dAdt is positive. Okay. Versus if your dAdt had come out to be negative, that would mean that the leg shortening ends up overall making the area shorten. Okay. All right. Number 6. You do, but we're doing the same delta math for a few classes because of how long it's going to take us to get through that. Yes. Where did your half go?
What?
Your half. Half would be 8. So your D should be 1/2. And then what's the derivative of the half would be?
You have to have a line to start.
And now basically we're gonna pass on this one. And then
People in like 2020 would be like, hey, this thing's black. Like, that's crazy. Oh.
for you to go back to the original, just like remember how those give you the X without the Y.
So crazy.
We'll give you the Y but not the X.
All right.
No, I tried to do that. My name was for me.
No.
Well, that's enough. All right, y'all, let's get started, okay? Okay.
Oh, yeah. You know, feel the rubber grenade.
All right, are we ready to get started?
No, you know I would never.
Yeah.
Used to be that one was good. Doing this before, so.
I was supposed to be in first. Okay, so what are you finding?
The area of triangle.
The rate, the area is changing, so what would that be? D,
The
D, Okay, and then they tell you how fast the base is changing and how fast the height is changing. Those will be your given. Oh, I'm sorry. Do you need me? Or you're just walking?
Yeah.
All right, how we doing? Okay. Yes, but doesn't it say that the height is decreasing at a rate of 30? So you wanna make your 3 but yes, and when you take the derivative, if it's 1/2 BH, you're gonna have to do product. Well, it doesn't matter, you can do the 6 times the 7. The order does 20. And then for this one, it's 1/2 of 12.
But if I
Wait,
think
no,
there was
okay.
any time to ask, I would.
Yeah, what half of No,
It's you, man.
Ninety that by 12.
So
5 or 12 would be still.
proud of yourself.
You'd be doing 12.
You're the same
plus
boat,
another
man.
half.
Oh.
So the order there shouldn't matter.
Can you just find out? I should steer quickly over. So we just find that area with the child.
Hold on, so 42 is the area, not how fast it's changing. So make this go back to the 18. Yeah. Uh-huh. I think, okay. Oh, wait, I think. What the, why are you doing that? Don't do that. Why are you timesing this?
Oh.
Huh? Oh, okay, okay.
Used to whatever it's called.
Yeah, you need to use the product rule for the derivatives. And then remember, I think, if you don't wanna redo it, I think we did that one on the front. Did you ever go back and write? Oh, you did find your.
Lions came in.
Sixteen, how do you get 12? I gotta get the wrong. Where's the 11?
That's 18.
That's 18. Oh, okay. I thought that was 21. So it's one half, you see how this is a minus? It's one half, so it needs to get on there. And this one.
What's that?
And then like.
Somebody.
Are we getting 3? Remember that, where's your half? So in your product rule, a half B is your U. Do you see what I'm saying? So it should be like this.
No, I'm cool there.
Okay, only because I want us to have a little bit of time for y'all to work on your homework. I'm gonna kind of try to finish this one. So when you get to this point, okay, you start plugging stuff in. So we have 1/2. My base is a 12. My DHDT is a -3. My 1/2, and then I get to B and I have a problem. Okay, I don't know the base. That wasn't given. Now I do know DHDT is negative. Oops, I think, did I put that in wrong? This should be an H. Hold on, 1/2 B DHDT plus what, this should be an H. And then a DBDT. Okay, and then DBDT was how much? 6? Okay. The problem is that you don't know what H is. Okay, question. Did they give you a different letter that or number that would allow us to go back and solve for it that we haven't used yet? Okay, we know how much is the area? 42. So if I know the area is 42 and I know the base is 12, is that enough information for me to go back and find the height? Yes, but remember, whenever you're missing information, you go back to the original equation before you took the derivative. So right here, I'm gonna put area equal 1/2 base times height, then 42 equals 1/2 12 times height. What is half of 12?
6.
So 42 equals 6H, then H has to be what? 7. And now I know what to put in this spot. So remember, when we were doing all the dy dx's, and maybe they give you the x, but they leave you on your own to find the y, or they give you the y, but leave you on your own to find the x. That's still gonna happen here, that you go back to the original before you took the derivative to find missing information. Now, real quick, why can't I plug the 42 in here? dAdt is how fast area is changing. The area equal to 42, that's not the same. So from here, half of 12 is 6 times -3 is -18. Half of 6 is 3 times 7 is 21. 21 minus 18 is 3. What will my units be if this is a dAdt? It would be inches squared per minute. Very good. Okay, so even though one leg of the triangle is getting bigger, the other one's getting smaller, overall, your area would be increasing because your DADT came out positive. Okay, there are two more examples we need to do, so let's just kind of run through them. Yeah. Will you set up two more left and then we're done, number 4. Okay, set up number 4.
Wait, but it's just because it's so close, you don't say like. Like it doesn't have to change. I found
It's a Warsaw, but no, there's
don't say.
Okay, y'all's giggle is so out of pocket. Like I was stressed and then I heard your little baby giggles there. No, I'm good. Okay. All right. Let's kind of lock in and try to finish these last two so you have time left over. Okay, it says a cylindrical grain silo with a radius of 8 is being filled with grain. The amount of grain in the silo is increasing at a rate of 320 cubic yards per hour. If it's measured in cubic yards, what is it a measurement of? Volume. So put dVdt equals 320 cubic yards per hour. Okay, remember, cubic yards and yards cubed are the same thing. Okay, then it says, how fast is the height of the grain silo rising? What are we finding? Okay, dHdt. And then they don't give us a when. That just didn't happen in this one. Okay, look back on the front of your sheet. What is the shape of the grain silo, it says? Cylinder, and we want the equation for? This is volume. Okay, what is the equation for the volume of a cylinder? Pi r squared times height. Very good. Now, normally, if I took the derivative of this, okay, I would have an r times an h. What rule does that tell me I have to use? Product rule. However, I want you to think about a cylinder. Okay, draw me a little cylindrical grain silo. Okay, a cylinder is like a cup. Okay, like this. Okay, if the grain silo is filled to here versus if it's filled to here, what would you notice about the radius of the grain silo? It would be the same. Here to here, how much does it tell me in the problem the radius is? Says it's 8. But even if the grain silo was filled to here, the radius would still be 8. So in this case, 8 is a fixed constant. It's not actually a variable because it's not actually changing. No matter if the grain silo is full, no matter if it's empty, because that's the container, your radius is 8 no matter what. So I want you to put a little note down here. Okay, that r equals 8 is a fixed constant. That means that it does not change in the question. So you can plug in r equals 8 before taking the derivative. Okay, you can only plug in fixed constants prior to taking the derivative. Anything else has to be plugged in after. So here's what's gonna happen to my V equals pi r squared h. Now it's gonna be pi h squared h. And what is h squared? So volume is 64 pi h. And now, when I take the derivative, am I gonna still need product rule? No, because the only letter left now is just an h. So what is the derivative of v gonna be called? dv dt. What is the derivative of 64 pi h? 64 pi dh dt. And then from there, we can just plug in whatever number we have, solve for the number that we don't have. So my dv dt was given to me as 320 equal to 64 pi dh dt. And then remember that in this case, I'm solving for dh dt. So how will I get rid of this 64 pi from the front? Divide it. So it'd be 64 pi over 64 pi. So dh dt equals 320 divided by 64. What are we gonna get? Close? 5. And then the pi would stay on the bottom. Okay, now let's talk about units. Volume was measured in cubic yards per hour. What will height's rate of change be measured in? Would it be yards per hour, square yards per hour, or cubic yards per hour? Regular yards per hour, because that's a distance. Okay. All right. Last one. Let's just do 7, I guess. Okay, and we're gonna run through this one kind of quick. Normally I'd try to have you set it up, but I don't know where the time went. So we have an air traffic controller spots 2 planes converging to a point as they fly in perpendicular paths. So let's put, here's my point that my planes are going to. Okay, let's say we have a plane A and a plane B. Okay, there's plane A. Ooh, I don't know what happened there. Okay, there's A and here's B. Okay. So it says one plane is 150 miles away from the point and it's going 450 miles per hour. Let's let that information be for plane A. So for my find, given, when, and equation, for plane A, we're pretending, because it doesn't tell us which one's which, that my dA dt would be how fast that plane is going. What would I put? The 150 or the 450? Which one is a rate? 450, because it's miles per hour. And then how far away it is would be a when. Because notice, he's not always 150 miles per hour or 150 miles away, but how fast he's going is his constant speed. Now let's talk about plane B. The other plane is 200 miles away and it's going 600 miles per hour. So let's do dB dt. What is its speed or rate of change? Is it the 200 or the 600? 600. And how far away it is would be the 200. Okay, so remember, A and B are measurement, dA dt and dB dt are speeds. They're how fast it's changing. Okay, one more question. Notice that my picture, my planes are going towards the same point. Will their distance away from the point be growing or shrinking? Shrinking. So what should both of these numbers up here be? Negative. Okay, from there it says, at what rate is the distance between the planes decreasing I want you to connect your planes with a third line. And I'm gonna call it C. And we're gonna do Pythagorean theorem. So your equation is gonna be A squared plus B squared equals C squared. And then I forgot to write what we're finding. It says at what rate is the distance between them decreasing? We're finding dCdt. Okay, if you will, please take the derivative. You can do it. Okay, go ahead and take the derivative and then start plugging in the numbers that you have. Y'all will need a calculator. C is the hypotenuse. It's the distance between the planes.
Well, we didn't label it.
You're taking the derivative of A squared plus B squared equals C squared, correct? You're taking the derivative of A squared plus B squared equals. Uh-huh. Johnny Cricket.
No, yours.
Why did you steal it? Why'd you steal it, Mom? I didn't finish this. What?
All right, look up, see if your equation is correct. Okay, it should be 2a dA dt plus 2b dB dt equals 2c dC dt. Okay, then I go to plug stuff in. I am expecting not to know dC dt. But I'm gonna notice that I'm also missing something else. I don't know C, but I want you to think about, if I know A and B, can I go back and find the C that goes with that? Using the same equation for Pythagorean theorem, but before I took the derivative. So you're gonna need to go back to A squared plus B squared equals C squared to find the C value. Okay, because if you don't know what C is, then you really can't plug in all the crap. So in your calculator, you're gonna do 150 squared plus 200 squared. And then take the square root. Oh, it's an even number. It comes out to exactly 250. Great. What was the big number here? Before you took the square root? 62,500, like that. And then it came out to be, you said 250. Oh. Okay, so then from there, now you can plug in all your pieces and get your answer. So 2a would be 150, dA dt was negative 450. 2b was 200, dB dt was negative 600. 2c was 250, dC dt is what we're solving for. Okay, to make this the most easy on yourself, type this entire side in at the same time. And then what is 2 times 250 over here? 500. So then to get rid of the 500, get that answer and then divide it by 500. That's the final answer? Perfect, thank you. Okay, dC dt equals 210. Oh, wait.
I got something.
Hold on. 2, 150, -2,
Yeah, I got a big number to
200,
store.
-600, divide by 500. Yeah, it should be 750. Close enough.
Oh, I thought, wait.
It was 750.
Wait. Oh.
Okay, now, quick question. Does it make sense that the distance between the planes came out to be changing in a negative way? Yes, where are they headed? Towards the same city. So does it make sense that as they get closer to the city, they also get closer to each other? Okay, yes. For your homework, okay, I would recommend sticking with the top half. Don't do any of the 2 formulas towards the bottom. Okay, but you'll have plenty of time to work on this homework. I know you didn't have much today. My bad. You have about 11 minutes.
Yes, sure.